Good day, everyone, and welcome to SoloCon 2021. And welcome to this talk to point you Gloo Edge users toward ways to improve your operational use of Solo's API Gateway product. My name is Jim Barton, and my colleague Baptiste and I are both field engineers with Solo. So we spend a good part of our days talking to both new and experienced users of Gloo Edge about the challenges they faced and about the solutions that they come up with to overcome them. Over the next 45 minutes, we'll share with you some of the lessons that we've learned from those discussions with the Gloo Edge community. We'll cover topics like understanding Envoy filter flow, security, profiling. We'll discuss tips on how to optimize your Gloo Edge configuration, both for production readiness and to better align with your team's areas of responsibility. Please note that this session does include some assumption of Gloo Edge experience. But if you don't yet fall into that category, don't worry about it. Just enjoy this session and then know you can also sign up for a hands-on Gloo Edge workshop that we're going to be sponsoring this Thursday at 11 a.m. US Eastern Time. So if you attend that session, you can then spin up on some of the fundamentals of the Gloo Edge product. And of course, we'll save time at the end of the session today to take your live questions. Now I'll turn it over to Baptiste to discuss Envoy filter flow. We hope you enjoy our discussion.
In this part, we'll speak about the filters in Gloo Edge, and more specifically, how they are organized and how they chain together. So first, a quick reminder about Gloo Edge. As you know, Gloo Edge acts as the control plane that will push Envoy configuration to the data plane, which is, of course, the Envoy Proxy. So clients' requests will go through the Envoy Proxy and its filters before reaching any upstream server.
But what does an Envoy configuration look like? Well, if we have a look at this simple Envoy configuration file, then you can see two different blocks. The first one is listeners and will define the server sockets. The second block is named clusters, and that will define upstream servers. A listener is bound to a network filter chain, and the most common network filter is the HTTP connection manager. This allows you to define routes based on domain names and on matchers. Here we have a simple matcher that will catch every request. This request will be applied HTTP filters with some specific configuration before being forwarded upstream. Luckily, Gloo Edge makes things easier by letting you split the configuration using custom resources. With the upstream CRDs, you can define Envoy clusters and some configuration in relation to those upstream servers. With virtual services or route table CRDs, you can define the filters and their options that will apply on a route. From this point, you may wonder how these filters are linked together. That's a good question. So let's go step by step. I first start with the XOUT filter. This filter will connect to the Gloo XOUT server, where you can configure different kind of built-in authentication and authorization policies. You can even build your own policies, and you can mix them all together. I will come back to this in my next talk. Now the JOT filter. So basically, you can verify your JOT signature and check its claims, and also add them to new headers. You can also apply this JOT filter before the XOUT filter. Now the transformation filter. So you can apply transformation templates or on the headers or on the body. If the body is a JSON payload, you can extract values from it. You can also apply this transformation filter right before the XOUT filter. And with those three filters, transformation, JOT, and XOUT filter, you can enable the option called Clear Root Cache. What is it? So basically, when the request comes to Envoy, then the HTTP connection manager will first select a route matching the headers. And when you add new headers with those filters, you can ask the HTTP connection manager to clear the route that was picked, and so that you will be able to dynamically select new routes at the end. And this is a really cool feature. So now the rate limiting filter will also call an external service called the rate limiting service that will apply your policies. And it comes with a nice API called the setStyle API that helps you to build complex rules really easily. It's really worth a try. You can also move, you can choose to move this filter before the export filter. This is a global option. And there are many more filters. I won't explain them all, but this is the big picture that I could draw here. So now a few other tips. First, the direct response. That is an option that will be evaluated at the very beginning of the flow by the HTTP connection manager. So if you choose to directly respond to your client with a 401 response, then this will be applied at the very beginning. Basically with most of the filters like rate limiting, CORS, WAF, when you set these options both at the virtual service level and also at the root level, then the policy set at the root level will take precedence. And finally, the airbag filter requires the JOT filter to read the principal. Just before moving to the next slide, I would like to add that all of these filters are applied only if you use the associated option. Otherwise, they are not active. So the final filter in the flow is the router filter. This one is in charge of adding or removing request or response headers. And it is also in charge of applying prefix rewrite, host rewrite, or regex rewrite. And also in charge of everything that is related to the upstream servers, like timeout settings and retry policies, outlier detections, and so on. As a final note regarding the XOT filter, when you use the OpenID connect policy, and if you set the callback path or the logout path, just bear in mind that the request will first go through these different filters before reaching the XDOT filter. So for instance, if you are using the CORS options, then your request will first be applied the CORS settings before reaching the XDOT filter for the callback. That's it for now. Thank you.
Before I started with Solo, I consulted with a large omni-channel retailer for some time. Their business had been flourishing for decades, and they had an extensive portfolio of legacy applications. But by this point, the entire organization was committed to modernizing their application portfolio. In fact, they were heavily invested in a popular Kubernetes platform and had a number of applications deployed in a public cloud. In fact, they were even given an Innovator of the Year award by the vendor of their Kubernetes platform. I guess spending a few $1 million will generate some award buzz like that. Anyway, when I visited with their development teams on the ground who were making all of this innovation happen, they all had one complaint about their environment that they loosely called developer productivity. To make a long story short, the root cause was this. Every single build into a shared development and shared deployment environment had a dependency on approvals from a central organization. And this had a big negative impact on the velocity of their development process and their ability to respond to the needs of the business. So first, I want to warn you that I don't have a silver bullet for untangling dependencies between the platform and development teams within your organization. But Gloo Edge does have a really useful feature that many of our customers use to help streamline operations by decreasing the level of coupling between platform and development teams. And that feature is called route tables. If you haven't used route tables before, you definitely want to take a look at these docs right here. Pretty good stuff. So let's illustrate with an example. So first, what I want you to do is imagine a simple, strange little world where you have two development teams. There's one that manages your custom version of the HTTP bin service and a second that manages the pet store app. And of course, you use Gloo Edge to expose these services to the outside world. So initially, you build a virtual service that maybe looks something like this, your simple little naive version. So you can see there's a pet store matcher here that delegates to an upstream, and there's also an HTTP bin matcher that delegates to a different upstream. So pretty simple stuff. And if we go in and apply this, not surprisingly, that's going to create a virtual service for us. And we can go run these applications, and lo and behold, there's the pet store service, and here's the HTTP bin service that echoes all of our input parameters. So all right, so that's really fine. But now let's imagine that somebody needs to make a change to the routing for this HTTP bin service. Let's say they need to add a hello world header that's going to be echoed out in the HTTP bin output. So logically, what they want is something that looks like this second virtual service. So it looks a lot like the first one. We've got the pet store matcher, we've got the HTTP bin matcher, but then we've added to HTTP bin this set of transformations here that's simply going to go in and it's going to add a hello world header to the response, okay, or to the request. And so I know this would never happen in your world, but let's just say that someone makes a mistake in the configuration and they break the virtual service. And now that it's broken, it's possible that it's broken not only for the HTTP bin team that made the change, but because all of this stuff is coupled in one virtual service here, it's also possible that the other pieces of this could be broken as well. And that's not something that's going to be good for our operational excellence metrics. So let's think about what we would do to set this up using route tables instead. It's very, very easy. So first of all, what we're going to do is we're going to establish two route tables. We're going to establish one that you would imagine might be owned by the pet store team, and it looks very much like what we had in the original virtual service. We create a second one here for the HTTP bin team, and it looks a lot like the original virtual service as well. And we've also added in our little hello world transformation here. And then finally, to tie it all together, we're going to have a virtual service, but it's going to be a much simpler virtual service than what we had before. So rather than encoding all of the routing policies and transformation bits directly into this virtual service, we're actually delegating this out to the route table. So you'll notice we're going to, for anything that looks like pet store, we're going to delegate this out to a virtual service that has a label called app that's named pet store, which you can see we've specified that right here. All right. And the same thing for HTTP bin, we're going to delegate off to a similar kind of label here. So this makes things much cleaner. We're now able to kind of separate concerns as they need to be separated, so the development team can manage things like routing and transformation for their app, and a central team can manage the kinds of things that they care about. Okay. So let's apply this and see what happens. So we will go in here. Let's apply route table number 1 for the pet store, and we can watch these guys kind of build up here in the enterprise console. There's HTTP bin, and finally we will supply the modified virtual service that uses the route tables, and now you can see we have everything right here And lo and behold, if we invoke our service, our pet store service still works as before. And now the HTTP bin is going to work, but you're also going to see a hello world header here in the output. Okay. So it's a very simple example. I understand that, but hopefully it gives you, sparks your interest a little bit if you haven't used route tables before, and will allow you to perhaps take a little step towards streamlining your own operations and making that just a little bit easier to achieve.
Okay, in this part, I will explain how you can build your own security workflow. So as you know, there is this XOAuth filter which connects to the XOAuth server where the authentication and authorization policies will be applied. Gloo Edge comes with a bunch of built-in features like OpenID Connect, OPA, OAuth2, and a few others. You can also build your own security policy. There are three ways of doing this. Either you start from scratch and you build your own XOAuth server, but you will lose all these nice policies. This is what you can do with the open source version of Gloo Edge, or with the enterprise version. There are two other ways. And the first one is by making your own Golang plugin that will run with the XOAuth server. In this plugin, you can implement your business logic. And the other way is by building your own service that will communicate with the Envoy filter over a pass-through system. In this latter case, you will be able to use the language of your choice as long as it supports gRPC. In both cases, you will be able to take advantage of the hotconfig custom resource by adding an additional configuration block that will be passed to your custom service. In this example, these two values will be passed to my custom service so that I can dynamically control how it behaves. Now, I will show you how you can compose security policies. In this hotconfig resource, there are two steps. First one is OpenID Connect, where the end user will authorize the client to retrieve user information on his behalf. In this second step, there is an OPA policy which will retrieve the ID token from the previous step and verify that the email claim is equal to this email address. If this assertion is true, then the request will be authorized. And finally, another example of how you can compose your authorization flow. In the first step, there is one more time an OpenID policy, and in the second step, you can have your own plugin that will query your in-house access manager, and this plugin can retrieve one more time the subclaim from the ID token, send it to your server, and the server can respond with the group that the end user is part of, and you can allow the request if this group is part of this list. That's it for now. Thank you.
A Gloo Edge customer reached out to us on Slack recently with a problem. They were moving toward a big production deployment milestone when they started noticing some really heavy resource consumption in their cluster. Specifically, they were seeing very high CPU utilization on the Gloo pod. How would you go about diagnosing a problem like that? Before we dive into that question, let's review some fundamentals. First, the foundation of the Gloo Edge data plane is the Envoy Proxy. And Envoy offers a local administration interface that can be used to query and modify various aspects of the proxy. If you're not familiar with it, I really encourage you to familiarize yourself with this web page here. It can be really useful when you're dealing with a lot of operational issues. There's also an excellent episode of the Hoot podcast by Solo's chief architect, Yuval, where he explores this interface in a whole lot more depth than we'll have time to do in this session. But we will provide all the links with the resources at the end of the session. So to access the Envoy administrative interface, let's set up a port forward from port 19,000 of the gateway proxy. So we'll do that here. So let's take a look at what we get. So here you can see there are a whole lot of services that this proxy, or that this administrative interface to the proxy provides. Just to talk about a couple of the ones that we see being used, I'd say most often. One thing frequently when you're trying to debug issues, you may want to set the log levels to say debug in particular modules, and so Envoy gives you some pretty fine-grained controls for controlling that. So you can just set all log levels to debug or info or whatever you want, but there are also finer grained mechanisms as well. So you can see there at the at the bottom, if you want to have just debugging of the WASM module, you can get just that. But just to show you, very quickly, it's pretty simple how it works. There's an interface here where you can post to that and say, okay, let's change everything to debug, and you'll see then all of the interfaces are changed to debug. So that's a pretty handy little operational tool if you're not familiar with that already. There are also ways you can look at, say, your Envoy configuration dump. So as you may know, Envoy is best when it's not deployed with static configuration. So one of the downfalls of earlier generations of API gateways is that they frequently required static configuration. And so when you had a problem, you change your configuration, you have to bounce the gateway instance, and that's really not a good way to do things if you can avoid it. So Envoy is strongly oriented around this notion of dynamic configuration, which is what the Gloo pods provide. Is they provide dynamic configuration to the Envoy proxy. And so if you want to see at any point in time, what does my Envoy configuration look like, you can dive in here and see, for example, what are the listeners that are configured? What does the actual filter chain look like to Envoy at this time? What do the clusters, which basically the upstreams, the endpoints that you're routing traffic to, what kind of clusters are available? Are they static? Are they dynamic? What ports are they looking at? That sort of thing. So this is some pretty useful information when you have a configuration issue and you're trying to understand, hey, my Gloo configuration, I think, says this, but yet Envoy perceives it as something else. So that's pretty useful as well. There's also a whole lot of statistics that are published, and you can of course export these to your own tools for analyzing. But just to give you a sense of the breadth and the depth of the statistics that are available, you can see there are literally hundreds and hundreds of things that Envoy publishes, even down to the level of what's happening with these specific clusters, what's happening with these listeners, what kinds of requests, what kind of responses am I getting to my requests, and breaking that down to pretty much a fine-grained level as you want. So that's all really useful stuff. And so the Envoy proxy administration is a really useful tool to understand from an operational standpoint. But if you recall, the original question that we started this session with was around profiling. And specifically, our customer has a problem with excessive CPU usage in the Gloo pod. So while these administrative services that Envoy publishes can be really helpful in a lot of operational scenarios, they won't really help us much in analyzing CPU usage in the Gloo pod. So what we're going to do is we're going to start by grabbing a CPU profile from the Gloo pod, and we'll analyze that using the pprof tool for Go. So again, we're going to first establish a port forward from the metrics port on the Gloo pod, which is 9091. So let's set that up here. And so there's the base interface, and let's set up another one here as well. So the first thing we'll do, let's actually go and kick off the profiling session that we're running just against this test pod here, which is pretty quiescent at this point. So let's dig into here. You can see there are a whole lot of different kinds of profiles that are available. The one we're going to focus on right now is this one, which is a CPU profile. You can have this run for as long as you want it to. We're just going to accept the default length for profiling, which is 30 seconds. And so we'll let that run for a little while. Meanwhile, we'll go back and take a look at the interface. So you can see that the administrative interface for the Gloo pod is not as extensive as what you get with Envoy, but still there's some useful things here. For example, if you'd like to be able to change the log levels for the Gloo pod, you can set debug info, etc., to adjust the amount of information you're getting. You can also take a look at the metrics that are published out of here, which is also pretty extensive set of metrics. And at this point, our profile has completed, and so let's go and we will kick off the pprof tool. And let's see what we have here. So this is what pprof gives us. And this is, again, for a pod where there's not a whole lot going on right now. So this is just showing a graph. Let's zoom in of some of the individual components that are running. And you got, length of time. And you can obviously see some of the dependencies between the various elements of the Gloo pod. There are other kinds of graphs you can look at as well. This one's a really popular one, the flame graph, that shows you kind of a different view of what's happening in your Gloo pod. And again, this is available for other pods in the Gloo Edge product as well. But if we take a look at just this graph view and we compare that with what we saw from this customer situation when they ran their own profile against this problematic Gloo pod that was exhibiting really high CPU usage, you'll see a contrast that just jumps off the page at you almost immediately. So you can see, if you compare the two, you can see an enormous difference right in this part of the graph right here. And if you zoom into that, you can see there's a whole lot of activity that's taking a lot of time around JSON modules that are unmarshalling and the processing that's associated with that. So the customer produced this profile and then sent it to Solo engineers for analysis, and just immediately it pointed us toward a solution around a new interface that was being used on the endpoint discovery interface. So if you haven't already, there's some really powerful tools here that are available both through the Envoy administrative interfaces as well as with Gloo. If you're having some kind of a problem, say with resource consumption under load, whether it's CPU or memory or something else, just know that these tools can help you, particularly if you also engage with us on the Slack channel and get our engineers involved. So we can help you isolate and resolve some of these problems pretty quickly.
Okay, this is the last chapter of our talk, and this is about securing the control plane for production. As you know, Gloo can discover services running on your cluster and across multiple namespaces. By default, it will watch all namespaces and write those upstream objects to the namespace where Gloo was installed. You can control the namespaces that Gloo will watch with a kind of a whitelist. And there are different kinds of upstreams that you can use in your virtual service. The most complete one is upstream, because you will be able to apply health check or connection timeout or failover on these objects, but this is not mandatory. You can just get with the kube destination type, which is a kind of a reference to a running Kubernetes service. And in this case, you don't need any upstream objects. I will show how it works in a minute. And just before, I will speak about the function discovery service, the FDS. This is a way for Gloo to discover REST endpoints or or gRPC endpoints, or even AWS Lambdas endpoints by scrapping existing upstreams. And you can choose if you want Gloo to scrap all upstreams or only the one that you label explicitly. And of course, you can disable upstream discovery and function discovery with this global option on your Helm chart. So now a quick demo. I have just installed Gloo with the discovery, with the discovery disabled. So if we have a look at the pods, as you can see, the discovery pod is not running. So it won't create upstreams for every Kubernetes service running on my cluster. It just comes with these two upstreams objects that are part of the Helm chart. And so now, if I deploy the HTTP bin application and I have a look again at these upstreams, so it was not automatically created. Well, this is just a simple virtual service using this kube destination type. And as you can see, I will be able to query the /get endpoint, and I still don't have any upstream referencing this upstream service. Okay, that's it for the kube destination type. Now I would like to enable again this discovery service. So I will modify my Helm deployment with this Helm upgrade feature. So this will add the discovery deployment. Let's apply it for real. Oops, yeah. So if we are lucky, the pod will appear. Okay, now there is this discovery pod running, and it will create the upstream objects for us. That's great. Now I will show how you can control the function discovery service. All right. So I deploy, the pet store application. Looks like it's deployed. If I get the upstream created by default for my pet store application, it is accepted. It is all good. So now, as you can see, I don't have any explicit label asking for the function discovery service to scrap the REST endpoints that are available by and exposed by this pet store application. So I will label this service, and okay, I have this new label that that tells Gloo to discover endpoints for this service. And if I run again this GlueCTL get upstream, now I can see my REST endpoints. That's great. So next stop is about invalid route replacement. It can happen that you have something wrong in your virtual service configuration. So my current configuration is this one, where I will match any domain and any path and route the request to the HTTP bin backend. So I can hit the /get path. Okay, I've got the 200 with the payload. It's all good. Now, if I modify my virtual service and if I add a new route on the /get, and if I ask Gloo to route these queries to something not existing, I am pointing to a not existing upstream. Let's see what happened. Let's run GlueCTL check and see what Gloo thinks. As you can expect, there will be some errors. Yeah, Gloo just say that he cannot find this upstream -bad. That's normal. And if I query this new endpoint, it works because this new configuration was not applied. And if I want this to be handled a nice way, I can configure Gloo to enable the invalid root replacement and to show the user a nice message with a 404 HTTP code, sorry, and let's query again the /get endpoint, and now I have my 404 error with a nice error message. All right, I hope you enjoyed. Thank you for watching, and have a nice day at the SoloCon.